Welcome back to PMC Tech and thank you for coming back. In today's video, we are designing a single-phase grid-connected inverter. If you are new to this channel, welcome. On this channel, we design MATLAB simulations. We also make tutorials on LaTeX, specifically Overleaf, to assist you in writing your professional documents like thesis writing, paper writing, and so on. We also talk about academic writing in general. If that seems interesting to you, kindly consider subscribing to this channel. So in today's design, we are designing a single-phase grid-connected inverter. A single-phase grid-connected inverter converts the DC input signal into the AC output signal. And to eliminate harmonics, an LCL filter has been designed. The specification of the single-phase grid-connected inverter that we are designing today are as follows. Input voltage 400 volts, output voltage 250 volts, power output 2 kVA, and the switching frequency is 10 kHz. The percentage ripple voltage is 10%. To design the filter for the single-phase grid-connected inverter, firstly we calculate the output current, which is given by the power output over the voltage output, and we get 2000 divided by 250, we get 8 amps. And to calculate the inverter side inductance, we get 4.425 millihenry. L2 is the function of the inverter side inductance and it gives us 1.327 millihenry. And the total inductance is given by L1 plus L2, which gives us 5.752 millihenry. In this single-phase grid-connected inverter, the voltage is measured at the grid side and then it's converted into alpha-beta reference frame. From the alpha-beta, the coordinates are transformed into the DQ reference frame. The alpha-beta reference frame has been used in the generation of the phase angle theta. At the inverter side, the measured current is transformed into the DQ reference frame. In the D-axis, the measured current ID is compared to the reference current and the error is obtained, which is applied to the PI controller. The output of the PI controller is applied to the pulse width modulator. The pulse width modulator has been implemented for the generation of the inverter switching signals. So let's get into the design. The proportion again is set to 25 and the integral gain of the PI controller is set to 6. We copy and paste the summing point. So the gain value is given by 2 times pi times 50 times the total inductance, which is 5.752 millihenry. So we copy this D-axis design and we make a design for the Q-axis. And we just change the necessary parameters. So here we set to VQ. And then this is ID. Remember here we are decoupling. And this is IQ. Don't forget to change the signs here from minus to plus. We now convert the DQ parameters into the alpha beta reference frame. Using the beta value, we generate the reference voltage for the pulse width modulator. Let's save the model before we lose the data. We label the inverter switching signals as S1, S2, S3 and S4. So we run the simulation. Here we are getting an error. The good news with MATLAB is it will tell you what error it is. So here it's saying the following voltage source block is short-circuited. So here we are, we remove the short circuit. We try to run again. What is this ugly waveform that we are getting now? Okay, so let's check the other errors that we could have made in the system. This just shows that sometimes we just don't get it right there and then, so you have to keep on trying and go through your system and see where you could have made a mistake. Okay, so here we've connected the current to the grid side instead of connecting to the inverter side. So we change to the inverter side. Let's run the simulation, then see what we get. And ta-da! So there we are. So we see that the voltage is in phase with the current. And the following is the output of the inverter current. So here now let's try to set our reference to 15 and we see how the current controller is working. So we see that the current controller is working perfectly well. Now here we try to send the reactive power. If we set our Q-axis to -10, we see that the current leads the voltage by 90 degrees. And if we set it to +10, we see that the current leads the voltage by 90 degrees. To implement this type of a controller in islanded mode, don't forget to watch this video. Remember to like the video, share with your friends and subscribe to the channel because this will mean a lot to me. Thank you and see you in the next episode.